You know your supplier does not get your application when they say, "Do not worry, we will make it through drawing," and then ask, "By the way, where does this part go?" If the word application makes them think of a job form, you may be in for surprises. Today, I will share 5 simple ways to judge if a supplier really understands your application so you can sleep peacefully and avoid those 2 a.m. line stop calls. I am Rahul Agarwal, Managing Director at Precitech Forgings and Engineering Private Limited. I work with purchase managers, sourcing heads, and supply chain leaders across the automotive and agriculture machinery sectors. I know your daily reality: tight timelines, cost pressures, PPAPs, new launches, warranty risk, and a plant that must not stop. On paper, many suppliers look the same. In practice, only a few truly understand what your part must survive in the real world. That gap between drawing and application is where most of the hidden risk lies. Let's be honest, many RFQs are dimension rich and context poor. The drawing has tolerances, material grade, and maybe heat treatment details, but it may not carry the why. The load cases, maybe the assembly process, mating parts, corrosion exposure are safety implications. Suppliers then quote to what they see, not to what your part actually does. Real examples I have seen: a high strength forged yoke passed all dimensions but failed in the field because the supplier did not know it faced cyclic bending plus corrosion from fertilizer dust. The heat treatment was fine for a lab, not for the farm. A steering component met the hardness specifications, but the fillet radius was treated as nice to have. Under random pothole loads, tiny corner cracks grew and warranty followed. A machined hub assembled smoothly at the supplier but jammed on your line. Why? Packing oil reacted with your paint process. Nobody asked about downstream steps. These are not bad supply story, they are missing application stories. Here is the uncomfortable truth: drawings don't fail, applications do. A correct part can be wrong for its job if the manufacturing window is not aligned to how the parts lives. And the biggest myth is sourcing is if the supplier is ISO certified and the PPAP is clean and the risk is low. Certifications ensure consistency. They do not guarantee relevance to your use case. The safety factor, microgeometry, surface integrity, and even packaging choices must reflect actual loads, environment, and assembly. When suppliers design the process around your application, your total cost drops. Fewer deviations, fewer escalations, and fewer firefights. Use these 5 signals to test if a supplier truly understands your application. They start with function and not just dimensions. They ask, what does the part do? Where is the highest stress? What is a failure which you cannot afford? They can restate your application in simple words and identify likely failure modes. Number 2, their questions are specific and little uncomfortable. Typically good questions like load type, static cycle, impact, temperature and corrosion environment, mating parts and assembly method. Any torque angle or press fit data. Which standards govern the safety side? If they don't ask, they cannot control. Question number 3, they translate your why into their how. You will see it in their control plan and process. Material melt route selected for toughness, not just grade, die design and fillet ready tied to stress path. Heat treatment focused on core or case. Decarb control if corrosion is expected. Machining strategy to protect surface integrity in critical zones. They identify CTQs critical to quality, linked to function, not only on print. Question number 4. They propose validation that mirrors your reality. Not just tensile and hardness, they suggest fatigue, salt spray, torque to failure, assembly trials, or gauge R&R for the tricky features. They are ready with a small, fast, iterative loop from sample to test to adjust. This is a sign of competence and not indecision. Number 5. They think beyond the part to the last meter. They discuss packaging orientation, rust prevention, handling damages, bin quantities, line presentation, and even the labels. They connect their FMEA with your shop floor pain points, mix-ups, oil contamination, burr at assemblies, fixture compatibility. If you see all 5, you can trust that they get your application. A quick story: a customer had a recurring field returns on a forged and machined bracket. Dimensions were fine, hardness were within the specifications. Yet failures appeared around a small internal radius. Instead of arguing about the tolerance, sat for an application review. 3 facts emerged. The bracket saw sudden shock loads during pothole hits. A nearby weld added local heat in assembly. The part lived in a coastal market with salt exposure. Based on this, the process changed. We increased the fillet radius, adjusted die parting to improve metal flow, modified the heat treatment to balance surface hardness and core toughness, added a decarb limit and a corner microstructure check, and switched to VCI packing with handling trees. Same drawing, but now aligned to the application. Field returns dropped. More importantly, everyone slept better. The big idea: application intelligence is your cheapest insurance. A supplier who understands the job behind the drawing will prevent the problems you cannot afford: line stops, warranty, and reputation. Use the 5 signals as your checklist. Function: first talk, sharp application questions, process tied to your why. Real world validation, last meter thinking. Before your next RFQ, please ask: have we shared the context and has the supplier reflected it in their plan? I'm curious, what is the one silent risk you have faced because a supplier did not fully get your application? Share your experience. Your story may save someone else from a late night crisis. See you in my